So I'm going to present myself just a little bit, and then I will give the floor to the speaker as well. So my name is Pierre-Damien Berger. I come from Grenoble. I'm one of the entrepreneurs of this area. We created a startup a few years ago, about few months ago, sorry, about predictive maintenance. I spent my times and most of my life first in a semiconductor company called Atmel. It was based in Grenoble. And then I spent 10 years in an R&D center called CEA, one of the most innovative centers said by Reuters last year. And this is where we develop few applications, few innovation, and this is the one that we start up last year. And I've been in charge of the IoT, I would say, overview in this 4,000 people working on R&D. So I've been deeply involved in the IoT business for many years now. And I'm really pleased today to be here with you and to share the idea about what's next for the future. So I'm going to ask the panelists to present themselves, first of all, and then we will switch on discussion about three main topics that I will describe afterwards. But first of all, this is your turn. Present yourselves, please, in about 1 minute each. It should be.
I'm Brendan. I'm an entrepreneur.
Try this one.
Go ahead. Hi, I'm Brendan. I'm an entrepreneur, serial entrepreneur. I started my first company at 16. In 1991, I started an internet service provider in Toronto. I've since done enterprise software. I've done cars. I've done boats. And now we're doing advanced sensors for the next generation of IoT. So I'm happy to be here, and thanks for joining us.
Hello, audience. I'm Antonio, and I'm work for Fraunhofer Research Institute. I've been studying, I have a PhD in artificial intelligence that I get in 2008, and I'm quite happy that now artificial intelligence is getting back on a lot of sectors. And I'm managing basically the business development because I always try to find what is the value add of AI or IT solutions. Within Fraunhofer here, Fraunhofer is the largest applied R&D institution back in Europe. We focus on 360 degrees of the research, spanning from biomedical to communication technologies. And specifically here in Singapore, we focus on computer graphics. That translated is data visualization through the use of technologies of virtual reality or augmented reality. And it's basically trying to translate insights from data.
Hello, everyone. My name is Yang from China. Working for Chinese Academy for Science. I'm doing research and development in the area of IoT. I'm the director for the wireless sensor network and the communication laboratory in Chinese Academy of Science. Also, I'm the director for OpenFog Consortium Greater China region. So we will mention the relationship between edge computing and fog computing later on. So my team has accomplished several influential projects in China. The most interesting one is the Internet of Things monitoring system for the south to north water diversion system, over 1,400 kilometers long. So we got some experience and painful stories to share with the audience later on. Thank you.
Wow, that's pretty impressive. Marc Overton, I'm with Cisco Jasper. So we're part of the new cloud IoT business for Cisco. Cisco is the world's largest IT company, one of the world's largest enterprise companies. Jasper was procured by Cisco this time last year to basically become the nucleus of its software and IoT business. Jasper is the world's largest IoT platform. We have over 40 million connections. We're growing at 1.5 million cellular connections every month. We power over 50 operators across the planet and about 9,000 enterprises. As part of Cisco, Cisco's ambition is to own the edge. And we're very much interested in partnering with people, especially people on the panel here, to do that. But we feel we have the assets, the global reach, the scale to absolutely make a huge difference in this space.
Okay, I think that we will add a microphone. Okay, it should work. Okay, so we're on the track of technologies. So we are going to talk about technologies, but not only, because there are many other things to say and to help us to understand. As I said, according to the title, Driving Towards the Edge, we thought that it was quite important before to go deeper in the discussion to define what is the edge. May I ask Cisco to try to answer? Okay, at least try. And some of the other people may add some other things. And of course, if in the room you do have some idea, or if you do have some question, please use the apps. Okay, you have a Q&A apps on your mobile phone if you want to have it, and then ask question, and we will try to also focus on the comments or the question that you may have. May I ask for a first answer?
No, thanks very much, Pierre-Damien. I've realized I'm sitting here with 3 doctors, which means that they're probably a lot more technically minded than I am. But I think from a business perspective, if we think about what we're seeing in the market, proliferation of devices, huge amounts of scale rollouts. We just heard one in China, where they're dealing with things like not enough bandwidth. The data is not particularly interesting. Not all data is the same, and therefore there's lots of opportunities to pick up data in all places. But actually, is it really valid and valuable? There's latency issues. There's partitioning issues. There's all sorts of challenges with actually getting the data back into the cloud. And what we sort of see it as a high-level architecture, if you like, is that there are loads of devices, massive amounts of things, devices that are generating a load of data. Coming back from that device, we believe that we have on the edge nodes, the ability to capture that data and basically, consolidate and coordinate that data. But there's a level of processing power that's happening there, but not necessarily, you don't want to bring the data back into the cloud, but you want a level of intelligence at the edge to manage that data. That then comes back through the fog to fog nodes, so into aggregating that data into more digestible form, so it can be filtered, and then it's brought back into the data centers where it can be leveraged and then back into the cloud where it can be analyzed. Now that is at a high level sort of framework where you go device to edge to fog to data center to cloud. I'll open up to my panelists to whether they actually see that process in place and what the role of the various elements are. But we believe in Cisco, given that we pretty much have an involvement in most internet traffic that's going on across the world through our gateways and routers, we believe that we absolutely play a pivotal role at the edge to help in that simplification, filtering, prioritization of traffic before it comes all the way back into the data centers and the cloud.
All right, I hope it helps. Maybe one thing which is maybe important to say as well, because once you have a kind of definition, as we had, maybe it could be interesting, Yang, to have maybe a kind of difference between maybe some other concept that we know, like cloud or like fog. Can you try to help us to understand or to make the difference at least?
Okay. As Marc just mentioned, the data will come from your device through the edge, and then fog, and then the cloud. So it's exactly the reason we are sitting here, that we want to put the intelligence, like Antonio is doing very well in his PhD study, that we put the intelligence from the cloud all the way to device. Okay, so by the way, the PhD actually stands for permanent head damage, so you don't worry about that. So according to my understanding, previously we think all the data should be centrally processed in the cloud because you got more resource, more intelligence, more complex algorithms over there. But later on, your device, your mobile phone is a computer as well, so you process your data locally. And we assume that the data transport through the network is a transparent channel. So you deliver the data from the device to the cloud. But actually, since we have so many routers and gateways, thanks to Cisco on this, those routers and gateways can put some, can integrate it with some intelligence. So they can deal with this data, process the data, give you a better understanding of the data locally through the parse from the device all the way to the cloud. I think that's the reason we have this edge computing sitting at the border of the network, and also the fog computing actually sitting between the edge and the cloud. Actually, it's everywhere inside the network. So give us more flexible choices in deal with your data. So that's my understanding. Yeah.
All right. It's a kind of funny because I would imagine to have a kind of family of clouds. You may have the small cloud, the medium cloud, and the big cloud. Is it something like this that you can imagine in our head?
Yeah, yes, there's also a consortium for the mini cloud, this kind of concept. But I think fundamentally, fog computing is different from the mini cloud. It's not just a downsized cloud service. Because cloud means you have a centralized processing. You do not want to share with the information with the neighboring devices. But the key difference for computing and edge computing is that it's more or less a distributed kind of structure. So you can share the computing resource and processing capability with the neighborhood. So
a different shape, a different color, and a different function.
Yeah, that's my understanding.
All right.
Thank you.
May I raise a question for Marc and Yang, and also for Bernard, because as Fraunhofer, basically here we focus more on the development of user interfaces or on way that people can interact with the data. Am I correct if I say that the edge is where pre-processing or filtering of data coming out from sensors happens? So to make easy then for the cloud to process this big amount of information and to maybe select, because we know that IoT is basically on monitor, measuring, storing, and then retrieving data. Is edge kind of supporting these processes, aggregating different sensors, let's say in a local area network, and try then to provide cloud with just the insights of what is useful or not?
I think you're absolutely right. And actually what we're saying is a lot of those devices at the edge will have an element of the cloud in them. They'll have software that can feedback when it's appropriate, when something is important, it'll feedback. So a level of intelligence at the edge is really important. So we're starting to see hybrid devices which have got software, hardware, that sit on the edge.
And we know that computing power and devices that produce computing power is always moving smaller and smaller. I think I read somewhere that Qualcomm is producing a cluster in 2 or 3 years. They will have computing power in itself, so it's just a device you put and measure all the data coming from the body, and this is leading to a different new business models and continue. Okay. Mm-hmm. I finished.
All right. No, that's really interesting because we do have different vision. I would like yours, Brendan, because you do have a kind of vision really oriented into the bricks, the technical bricks. Can you tell us more which kind of bricks will support this kind of vision or this kind of concept, or in terms of calculation, in terms of processing, in terms of all of this?
It's an integrated environment, and it's really depending on the application. There's a lot of applications that are very well suited just from the mobile to the cloud, let's say. It's not time critical, it's general, it can use Wi-Fi, it can use 3G, it's great for that. And a lot of the initial IoT applications, I think, we're leveraging this available technology. Then we started, I guess, diving into more difficult commercial applications in fabrication, manufacturing, industrial. And we start to have issues with latency, where we want now the network to control a machine based on information that is being received. Latency might become an issue, where the cloud then is not really sufficient to provide that critical, time-sensitive sort of feedback. So the edge was introduced. The edge is a logical concept. It can in the issue of latency alone, it can do some of the pre-processing and react much quicker than the cloud could. and provide even network services where no terrestrial network exists, where you only are isolated to the plant environment or the LAN. The Crux Photonics, we're looking at the next step. We're looking at applications that are critical in nature to where even an edge node communicating from the sensor devices to that edge node is defeating the power efficiency that we need to achieve to run on battery-operated devices, where the applications might not facilitate cables, where there's no terrestrial network, where they're critical and large scale. Let's say if we were to monitor this entire facility for its structural integrity, and it, in the case of a ship, is floating in the ocean, there's no terrestrial network, and it's very critical that the regulators and the operators and owners know the condition of that ship. Currently, with let's say a 5-year inspection routine, manual inspection routine, this isn't good enough. I think it's not good enough for all of us, the safety implications of that. And there's a big willingness by these industries to adopt these solutions, but they're not really practicable in some of the current technologies. So looking beyond that, we're looking at fog analytics and analytics on the end node devices, on the actual sensors themselves. So these are sharing elements. They'll definitely work in conjunction with an edge as a gateway device at some point. But we want to figure out on that vessel itself, let's say, or on this building itself, at this moment, is it okay? Does any corrective acts, does any information need to be sent, no matter where it is in the world? And this is requiring advanced technologies, hence photonics is our area, and this allows us to get into this low-level, high power efficiency, hybridizing technologies together, and this is the area we're focused on.
Before to go to, because I thought you wanted to talk about technology and then after application, but you started no, but that was good because the link was good. You are talking about application like monitoring these kind of buildings.
That's the case.
Are we talking also about the edge or about the different type of clouds or calculation for any other IoT application? Are you talking about, or can we talk about applications like wearables, or can we talk about connected shoes, or is it limited to any type of application, or is it for any kind of application?
No, there's application-specific fit for purpose, let's say. Can
you give some example? Try to imagine.
Connected a Fitbit, sort of a watch, to record your how many steps you've taken over the last year. This is fine for the cloud. It can be transmitted from your mobile device and stored on the cloud. It's not that critical. I mean, it's not the same sort of application. So it's very application specific. Mm-hmm. There's very many applications, as I said. It's an integrated environment in this case, but the application for a lot of these wearables is not requiring this level of technology. The cloud is fine.
Okay.
Another I think manufacturing is a great area that really leverages the edge, because you have a lot of critical controllers on the machines and things. So it's a completely different application. It's all under the IoT umbrella, but the technologies and the requirements are far different, and the value quotients are much different.
Okay, Marc, some idea?
Yeah, no, I completely agree. And we've got, at the moment in IoT, and certainly with Jasper, we focus on cellular IoT use cases. It's quite expensive to put a SIM card into all these devices, and to actually put that investment in. A lot of these devices are going to be microtized. They're going to be very, very small, very low power. So narrowband IoT, Cat-M, all these other technologies I think will help. But actually, do you want to take, to your point, the information off that device? Is it relevant? What can you compute locally? How can you get it back to the gateway? And the gateway will obviously be the cellular connected piece that will bring the information back. So it's that interplay between what makes sense to sit at the edge and what sits in fog and then back into the cloud. And I think that will depend on use cases. I think we see a lot of applications for the edge in things like smart refineries, smart manufacturing, Less so in some of the consumer pieces, but at the moment, the real change we see is enterprise. And you were saying the water case, it sounds fascinating. I mean, it's that huge scale deployment of connectivity solutions that demand different approaches. Do you want to say something?
Good transition. Go ahead, Young.
As Marc has mentioned, the mega project for the water monitoring or transportation system involves about 100,000 sensors from more than 130 companies. So it's a nightmare to get them connected to the center. So before we have any technologies like NB-IoT, we just rely on the existing communication solution, which is very expensive, not very energy efficient. So we try to maximize the local processing of all these devices. We transmit a limited amount of information to the cloud, and the data traffic is actually on demand basis, so that we can minimize the cost and the energy consumption for this long haul communication. Yeah.
No, more than answering, I wanted to make an observation also, because now I really shaped the age. I think there's hardware and there's also software that are working together within the age. And one thing that we should always keep in mind is that there's data. And most of the times data are mirroring IP. The data, I'm thinking about industrial IoT. Most of the times data represent the core value of an industry, for example, or a manufacturing company or something like that. So it comes also issue related to the security of data, or what data then you can decide to share with your supply chain outside the edge or outside where the overall environment of IoT is done. And I think that it's much easier to manage this hierarchy level of access to the data, which access to the data from an edge application or an edge middleware, for example, than from the cloud.
Okay, I'm gonna play with the question, because the tool is here and the people are playing with. There's one question that I find really quite interesting. Say, who defined next generation? So please comment on graphene, nanotech as a player. I'm not gonna give some more detail about that, but for me, who can define the next generation is the user. So of course, it's quite an easy answer, I would say. But what I think and what I've seen in the past and in different type of application that I've been involved, the most important request is from the user. So if the user needs a better communication, a better storage, or whatever, that's going to be my answer. Is there any other question that you can bring into
I'd probably address this a little bit.
Exactly.
In the area of graphene and nanotech, well, nanotech is a very broad discipline. I mean, inorganic chemistry, advanced materials, functional materials, however you want to slice it. And there's so many, such a range there. We're also interested in nanotech, but we're interested in the energy harvesting aspect of the thin films. Thin film energy harvesting, so we can have a long service life on batteries, slowly recharge them from vibration or from solar recharge or whatever. This is a very important area, of course. Graphene, very application specific. Graphene is, one of the problems is limitations, let's say, is in manufacturing. You got more to say on graphene? No. Graphene is quite interesting. I'm not sure that the latest state of the art, but generally it's they're challenged to make this material quite pure on a large scale. So I think this is graphene and nanotech are not necessarily a good side by side, but there is applications for graphene, and as a material science, you can find it for electronic semiconductor applications, even photonics, waveguides and optical properties of graphene. It's too much to cover, I think, in the scope of this discussion.
Okay, Antonio, maybe one answer because you're mentioned in the question.
Yeah, no, I was thinking that from my perspective, the next generation, as you mentioned, it will be dictated by the user. The way I see the development, the further development of IoT is basically in integrated IoT, where you can integrate in one single sensors the ability to monitor different parameters within the same environment. Mm-hmm. I make an example. Now, for example, street lamp, they have sensors that communicates the consumption of energy, or for example, if the bulb is on or off. But it would be also a lot interesting for policymaker or for actors also to know information about the traffic, about how many cars are passing under the traffic lights, in which specific time. So this is basically, you need multiple sensors, but if you're able then to integrate the ability in the sensors to collect different kind of information, then also reduces the cost for the end user to have this information. Or for example, temperature sensors in a room, if they can be then merged with the ability to get also the number of people in the room, as well as also the humidity level in the room, as also other information, this can also be a value add. So from my perspective, the next generation stays on integrated IoT sensors, and then nanotech and graphene will see, okay, nanotech, yes, will play a key role. They are enabling like material and enabling technologies for conducting the information, graphene basically.
Okay, so I believe that those kind of information are important to understand where we are going to and which kind of application also we may have with this second generation. I don't know if it's the right words for that. Regarding, I would say, the application, this is the business model, which is also interesting. So we go deeper in the definition of this second generation, because we need also to, we need to also understand the business model, because who defined as well the application or the second generation is first of all the user in terms of functionality, which are brought to their environment, but who pay for that? That's a good point as well to talk about. Is there any evolution that you can foresee in this topic?
I think that Marc already gave the answer on the business model when he said we want to own the edge. So that is the answer, I think, to the question. Basically, it makes sense. I mean, Cisco wants to own the edge.
We want to own the edge, or we want to make the money on it?
We want to own it first, and then we'll make money later.
Then you sell to the others some pieces. No, but of course it makes sense. As I mentioned before, we have always to keep in mind that data are the first, where the value stays, where the value resides. If you can control which data I can give it to you, then I think that then I'm good in it.
I think data is an often used, obviously. However, it's information, it's events. This is what the owners want. From a technical aspect, we talk about data, we understand it. But owners of people who are going to buy into IoT, they want economic benefits. They want to reduce risks. They want to improve efficiencies. They don't really care about data. They care about information. If that information is information about critical events that they must be aware about to take certain actions, then so be it. So it's really about that. And I think the edge and and everything that we try to do is try to bring that information to the enterprise. This is still enterprise IT, really, reaching beyond the office, let's say, or reaching outside of the corporate headquarters. It's reaching out into the field, but it's all about the information.
Mm-hmm. More words about business model. So Marc, maybe we will switch to the question afterwards, because I would like to give the red light on this discussion. What do you think about the evolution of the user and of the business model of the company? What are the vision in this field?
So, as the world's largest router and gateway company, we're very happy to sell kit that sits on the edge, because obviously that's our primary business model. But adding the software dimension to it, and absolutely what you were saying about the event-based. So we're seeing this with narrowband IoT at the moment. You know, is it the same business model as cellular? It's very small amounts of data, more event-based. You know, and actually, is it more session-based, API calling rather than data usage? We're wrestling with that at the moment. My belief is it is going to get more to an event-based model, a more user-based model, as opposed to a usage-based model from a connectivity standpoint. It has to, because the amount of data is tiny, but that data could be massively important, as opposed to a big data package. A needle in a haystack, absolutely. So I think for us, it's two business models. Firstly, owning all the routers and switches that sit at the edge is a good place to be, because there's going to be a lot of demand for that to hold all these nodes together. But actually, secondly, it's redefining that business model. And that's a really tough place to be, actually, because at the moment, in our experience, IoT is data-driven. It's quite big data bundles. It's connectivity-driven. If we're going to go to event-based, that's a very different approach.
And how does Cisco thinks to manage the data ownership? If you own the edge, it doesn't mean that you own the data.
That is true, absolutely. No, I agree.
As soon as you can use them.
Yeah, no, exactly. It's not our data, or data. Router, router. But no, absolutely not. No, we enable, facilitate that, and we are absolutely open to all devices and all applications in that space.
There's an interesting a business model could be based or in the M2M, machine-to-machine world. They have interesting business models. Billing based on the information that's being generated by the network facilitators. And this is interesting because we often talk about, well, how much is it going to cost? And it's very things-based. It's hardware. A lot of it is hardware-based, be it the edge device, the sensor device, even the display model. You know, there's a lot of hardware behind that. NVIDIA's, by example, somebody will be powering the displays and so on. So how do we, with challenging economic times, how do we introduce this new, pretty well expensive hardware and these expensive propositions that are at the same time going to save these customers all kinds of money? This is one of the challenges in going to market with IoT. Mm-hmm. There's a lot of generalized benefits, but the economics is still challenging, especially if you want to develop things like we're developing in the photonics and graphene or next generation sort of technologies. So billing and the information, the value of that information, the relevance of that information, and the value it is to the organization, this introduces a lot of interesting possibilities for business models. For IoT.
And then you introduce the difference, of course, between cost and value.
Right.
Well, that's also important.
In a traditional case, you would
remind.
sell $1 million machine, let's say, and you go back 3 years later and try to sell upgrades or a module to it or a new machine. That's being harder to do, and it's less interesting for the owner, who might be the owner or the manufacturer. If they could develop a relationship and earn value over 10 years, and you know, this is a much better way to get to market. So this is an interesting space, I think, for the future, how that's going to develop in the business models.
Because we are in the business model, we are on the price of the product, or of the service. There's one question that I would like to play with today. Also, it's what will be the main advantage seen by the citizen with such a new generation of capabilities? Maybe we can try to answer to this question because we were talking about business, we were talking about price. Are we talking only about price or functionality or service? It's a kind of mix. Antonio?
What I think that will be the main advantage seen by the citizen is also you have to consider that the majority of the data stored will also be used for policy making. If you see from this perspective, like policy making also based on insights gathered for data that's summarized. Of course, I mean, in a democratic place should be an advantage. Then It depends how this data are used and manipulated, but usually also you have an enhanced access to informations. That is the way I see the advantage for the citizen. But you don't have to consider the citizens as the only user, because users will be like in industrial space, aerospace space, it will be a lot of sectors. So from the single citizen, I think the advantage is that can optimize the way he lives or of the neighborhood, then it's managed by the people who should develop policies or so on. That's my view.
Some other questions, some other answer?
So my understanding is that our current solution for the citizen, for the users, is to provide tools for them to collect data. So we are usually surrounded by too much data. So as Brandon said, we care about events, we care about information. So I think the next generation IoT capability will actually provide a service to the users. It's not just I give you all the data you may interested. I give you
the tool into service.
Exactly. So so hardware, software are part of this service, and more importantly, the intelligence, the analytical approach to understand the user, the citizen needs, and then provide the right service, the right information just on time. That's the key value for the citizen, for the next generation IoT.
I think we'd want to be very optimistic and say that all these advantages will trickle down to the citizen, and let's say it does. In a situation where we're providing, let's say, critical safety systems by IoT, and this is an area that we're focused on, then natural environmental protection. This is a very relevant thing to citizens. The integrity of the vessels, or integrity of the structures and the bridges and things that we drive on, the effective and cost-efficient inspection and maintenance of infrastructure. It has a trickle-down effect to the citizen. So it may not all be so consumer-oriented that there's a immediate go to the IoT store and buy something useful that benefits your life. But overall, as the information age in itself has benefited society, this is a continuation, and there'll be continue to be benefits.
Okay, one maybe crazy question. According to the business model, according to the price or to the value, and according to the data collection that this type of device will be able to do for us as a citizen, could we consider that there are different type of data and different value of data? I mean, is there any priority in terms of data? And the idea that I do have behind this question is there how to define which kind of new business to take as an entrepreneur, for example, or to target or to see any kind of data which could be really high value to make a new business. Is there any kind of thinking from your side, or try to answer to this question, or to maybe help some entrepreneurs who would like to get a new market and make a new business? Is there a kind of priority in the data that which are collected?
So I think we're already starting to see that in the traditional IoT space. So the connected car space is a good example, which, if you'd heard me speak yesterday, I think is driving a lot of the innovation in IoT generally. So the traffic classification, the ability of connectivity to be prioritized, quality of service to be premium, in order to enable critical applications. So critical application in this sense is an autonomous vehicle where it needs to be always connected. That is going to fundamentally change the way in which cellular networks and indeed fog computing is configured in the car environment. So the innovation that we're going to see in that use case, I think, and the business models that come out of that, will potentially drive other edge and critical data applications. I'm sitting a lot with the OEMs at the moment across their autonomous vehicle strategies, and they have demands on connectivity that are absolutely way out there. They are changing the way in which we price, prioritize, configure data, and I think that will come across other use cases.
Thanks.
I'll address the entrepreneur word. You said entrepreneur, so there are things out there for entrepreneurs. I don't know, you would have to ask them, I think. I
tried.
In our case, we're doing structural health monitoring is our focus. We find this is a lot of latent markets that are in need of this application. So as an entrepreneur, this is something that I've hooked onto that's IoT oriented. But you've seen a lot of entrepreneurs or heard about them come up with parking spot allocations as an IoT application. Of course, the fitness resurgence, and I think there's a lot of room for entrepreneurs to get involved. However, I think the bar has been raised a little bit. IoT is the low-hanging fruit is pretty well picked, and not just the simple device, but also in the software area, an internet type of app, the mobile app. So it's a good question.
All right, it's not a
answer.
crazy question, all right.
I can see not what I think that an entrepreneur or which is the sort of data that they should make advantage with. I can tell what happens in the last 1-2 years within Fraunhofer, because we received a lot of demand from the market to properly visualize data and to properly let an user to access specific data. That could be water consumption in a simple flat, or there could be energy consumption in a building compared to other neighborhoods. So this also should really underline the importance of data, and also the underlining need, the need that is there for some user interface or some easy way also to understand the data and to interact with the data.
Okay, I will switch to another subject. Before to go on the other question about blockchain, I would like to talk about standardization. Is there any, I would say, already existing standardization, first of all, on the IoT, and what's going to be the next standardization for the next generation of IoT? Complicated question, I believe, but can you give us an overview, Yang?
Yeah, I can see that IoT standardization is underway in many different organizations. Also, for edge computing, we have edge computing consortium in China. They try to push the standardization and the ecosystem to be healthily built up. And for computing, we have this OpenFog consortium funded by Cisco, Intel, Dell, Princeton University, ARM, and also Microsoft. So we are currently working with IEEE to promote the standardization. So this consortium of OpenFog is focusing on the technology and also the business model development, the reference architecture. And then we deliver all the key content to the IEEE to go through the IEEE standardization process. I think this is a crucial part of the work, because IoT applications is so diversified. So you need some consensus on the application, and you need a very intensive discussion, especially with the vertical industry, to understand their real needs. So that's my understanding. And another thing I believe is that the approach for IoT may be slightly different, because we have so many diversified applications. So I certainly believe that software will play a key role in satisfy the needs from different vertical industry and the technology availability. So software will solve the gap between the requirements and the technology readiness.
Okay.
Yes, that's my opinion.
Okay, just maybe 1 minute, no more, because we do have a conclusion to make at the end. What about the blockchain? The question from Tom is, does blockchain technology has constraint which could limit, I would say, limit IoT development? My point of view would say that blockchain will help, or which give, I would say, a certain way to work for certain business, I would say. I think that there are many other IoT business which could be run without any blockchain, okay? But for some reason, blockchain could be useful. Maybe one comment in less than 1 minute?
Well, blockchain is two elements of blockchain to consider. One is it's process intensive. So it's going to take a lot of processor power to generate the blockchain function. However, it can be used very efficiently. This is something that's well suited for the cloud. The cloud can provide this processing that's required. But it's very good for setting rules. When you have a machine learning type of systems that are adapting, and a new threshold has been reached or discovered, and blockchain is employed to pass amongst regulators, or let's say, and different components to verify the data, agree, and then you said, okay, this is the new benchmark, or this is the, we shift the goalpost to this point. So blockchain can be leveraged, I think, quite importantly that way. I don't think it has a constraint other than its processing, it's processive intensive.
Thanks, Brendan. I would like to finalize this panel discussion with a movie. So I think it's also a way to give you an overview, or at least one example of an IoT example, which is really close to what we can call the edge, or something which will be much further than, I would say, a wearables or a connected car or something like this. This is a service, a complete service. So let's imagine that you may have a possibility to deploy a technology all over the world in different type of structure to be monitored and to make a kind of risk management and cost optimization. Can you send the movie? So above, I would say, the deployment of the different type of sensor that we can make onto this type of structure, we can foresee, I would say, all the process which can be done at the node level, or at the cloud level, or maybe at the edge level. Okay, so there are many different applications that we can foresee. And of course, if we manage to have a kind of prioritize of the data, a priority in terms of decision, a kind of comparison between different type of structure in different places, you may have the possibility to imagine, I would say, any kind of new services in this domain. But there are many other domains which can get a benefit of the deployment of many sensors, so deployment of the technology to serve at the end of the day the user. So maybe there's only 20 seconds left, maybe 1 or 2 words to conclude this panel discussion. Go ahead. One question, one word to define the edge, or to define what's going to be the next for you. Who wants to start, Marc?
As I said, Cisco looking forward to powering the edge. I think it's absolutely fascinating. And I think we are well placed with our hardware business, but also now with our software assets to really enable that and work in partnership with people to monetize it.
Good. Okay, Yang?
Yeah, as I mentioned, IoT is all about service. So we will integrate hardware, software, and intelligence into the whole system, not just on edge or cloud. It will be everywhere. So that will be the next generation IoT capability.
Thank you.
Thank you.
Yeah, as I mentioned, my view is integrated IoT will be the next generation, probably with embedded some AI facades. But I would conclude, like, try to find the right data to generate, then you will make money.
Good.
I'll concur with the panelists. Absolutely. It's about going where we haven't gone yet. It's about extending IT really out into the physical world, to the things.
All right. So I just would like to wish you a good challenge, good business in this IoT domain, and I would like really to thank all the panelists. So thanks to all of you, and enjoy the rest of the event.